There are a number of inbuilt functions that you can access to make it easier to create arrays more quickly. For example, if you're familiar with matrix methods, then you'll be pleased to know that you can create the identity matrix by using the I function. Here is a 10 by 10 identity matrix. The reason for the strange command name EYE instead of just using I is presumably because we don't want to have a conflict with the imaginary number I, which people will very often define to be I in their calculations. To create constant arrays, we can use the ones and zeros functions. Zeros, 5, 4 makes a 5 by 4 array of zeros. Ones, 5, 4 makes a 5 by 4 array of ones. If you use just a single argument in either of those functions, then you'll get a square array with the same number of rows and columns. We can generate other constant arrays by using the ones command. So, for example, this one gives us an array of 3s. It's also worth noting here that we can create arrays with more than 2 dimensions. For example, we can do D equals zeros, 128, 128, 27. I should have put a semicolon after that expression because, as you can see, the whole screen is now full up of useless zeros. Let's clear that and put a semicolon. The array D that we've created here could be used to represent points in 3-dimensional space. An example of an application using this technique is storing the data from MRI scans. The numerical values in the array represent the intensity of the image at each point in space. We can actually load an example of exactly that. Type load MRI and this will load some example MRI data from MATLAB. The data that MATLAB loads is actually a 4-dimensional array, but I'm just going to do an operation here that will get the results into the format that we want, which is 3-dimensional. We can see now that D is 128 by 128 by 27. The values are integers, but these integers are going to represent the intensity. We can take a slice from the array by typing D colon colon 10. So this is going to get all rows and all columns from the 10th slice. It's the entire 10th layer in the array. And we'll show the results using imshow, which is used for showing, visualizing data that are stored in an array. So here we've got a slice of MRI data. The function randy creates an array of random integers. For example, we can do randy 099, 3, 5, and this will create for us a 3 by 5 array of random integers in the range from 0 to 99. You can also use the random function to generate an array of normally distributed random numbers in the range from 0 to 1.